what we did yesterday. But in the interim, we can just go over, and then I can come over to assist if you have a problem. So basically, we use the Apex editor to control or try to talk to our model after setting it up in the WinApex interface. So once you set up your model and it is running, you don't have to always go back to the interface to do stuff. You save the original copy of your model, which is running, in a separate folder and keep it there. So that as you progress, if you have problems, you can always go back to your original file, which is running, bring it, and then try to trace what the problem is. Otherwise, if you don't do that and you miss the master copy and you have a problem, it means you may have to start all over again. So at each point, you can just save a master copy when you know that your model is running very well. So yesterday, we went through the Apex editor file. So you saw how the structure looks like. So there are a number of programs that we use to talk to the model. So okay, let me just project, and then I'll just show the Apex editor, and then once it's here, you can just use the phone to show the different things that we do. Otherwise, it will be difficult to visualize.
Okay, you need this PDF in projector? So?
Yes, if you want, you can project your own phone.
Okay, you can give me a cable. It's a cable. I will share for you.
Which one?
Just this one.
Yeah,
Here. No, no need for it. It's active. कोई project ला रखा
step by step. Yes. Okay, thank you.
Can I show you? Let me make it.
So this is the general structure. So we have this extended in an Apex Editor Excel file, and you have each of them. Thank you. You have each of them governing a process. So when you look at this step-by-step procedure, you have a detailed description of what each of them does or contributes to the running of the model. So like we learned yesterday, these are very easy. You know that this consists of a number of tillage operations. And it also gives an information of the different machines that you can use for an operation. So for example, if you want to tend the land, you can have information on whether you are doing it manually, whether you are using a plow, whether you are using whatever material that you are using to do this operation. You can specify so that the model will know. And then when it comes to pesticide too, you know there are different pesticides, there are different fertilizers. So here you can just specify and give the details of the fertilizer or the pesticide, and so you come to the list of operations, which is the main area where we do our schedule. So each of them is clearly described in the model. It's not complicated. I know that when you see it at first, it may look like it's a lot of things, But once you go through it, you see that it's very easy because everything is explained in the Apex database itself and also in the step-by-step procedure. So we can go to the editor now.
Excel.
Okay.
In the bottom.
This one.
Yeah.
Okay. So when you open your Apex editor for the first time and also in subsequent times, you remember that sometimes you will either have between 2 to 4 headers. So sometimes the header will be 1, 2, 3, 4. Sometimes it will be just 1, 2, 3. Sometimes just 2. Okay, excluding this one, which gives the details of what each of these is. So, for example, if you go to the apex file dot that is just 3, and then when you go to the parameter data set, for example, you have 4. So the key thing to remember here is that whenever you have a file which includes get file, read, write, run Apex, don't be too quick to view what you want to view. The first thing you would want to do is to go to the get files. Okay, so for example, for this one, if you open it right now, you will see that it's just this. Okay, and then it starts with 90, 99. But let's see what the get files will give us. You see that it has given us something different. So assuming you don't go to the get files and you just read, you will have an error. So once you make a change in the database, for example, if you want to change, and mind you, before you change anything, you have to understand the process behind it. Why are you changing it? What is driving the process? So if you make a change in this document, write is like save. So if you want to make a change and you want it to reflect, then you can just go ahead and write. Once you write, it is saved. And then like I mentioned, once you have this, you don't have to go to the interface to do anything. You can simply run your model here and then it will work perfectly. Um, so yes, we've talked about the get files. And then still in this area, when you go to the operations file, here, when you open your Excel file for the first time, this comes as OPC. Okay, so the key thing to do here is to also change the OPC to OPS. If you don't do it, you will have an error. So you change OPC to OPS, and you see that there are 4 of them here, and so you would want to go get your files, and then a list of all the operations that you have performed and saved will show up, and then you just go ahead and select the one that you want to work with. If you don't do this, you may risk overwriting some of the stuff that you've done before. So key things to do here, first look at the header. If it's just 3, read, write, run, you can just go ahead and read. If it's 4, get files, read, write, run, the first thing you would want to do is to get the files, go through the list, select what you want before you read. And then when you come to the operations, the main thing to keep in mind is that once you open your editor for the first time, you would have OPC. So you change it to OPS. Is this clear? Yes. So, boss, can we have your laptop so that we can have this phone in practice? It's fine.
You can use.
Okay, thank you. So yesterday, but I need a snapshot of the exercises. Do you have it saved?
Yeah.
The questions.
No.
Okay. Because we would like to refer to the question and how it was solved. Thank you.
በደቂቃ እንዴ ታሰረ ታሰረ መጨረሻ ላይ የሰራናት ሁለት አንድ ሁለት ሶስት ናቸው። ሶስት አራት አምስት ደግሞ ሁለት ነው። አምስት ሁለት የመጨረሻው 30 ይሄ ከላይ ያለውን እንትን ላይ ይሰራል። ሙሉ ወርታች ሳይድ ማለት ነው። ወርታች እሱ ታች ላይ ቢሆን መሆን ያለበት የላይኛውን ሁለት የላይኛውን ዛጋ 292 073
Okay, so
0 መሀል ላይ
you were given
ኦፒቪ
some
3
tasks
ላይ
to perform
ኔጌቲቭ 9
yesterday. So the main thing you would want to keep in mind is that you have a plot of land. What do you want to do with it? What do you want to grow? Before you grow, what are some of the activities that you conduct in the field? So one thing I like about this model is that it's very practical. You can relate directly to what you do to the field, so it's easy to manage based on what you want to see or what you want to get, right? So for the first time, we were asked to plant corn with no fertilizer. Okay. So we have okay. Plant corn with no fertilizer. So we were given a number of tasks. This may change depending on what you are interested in. So we have plow on May 15th. We have to plow on 1st June. We have to plow on 15th June. We have to plant on 15th June. And then we have to harvest October 15th. So whenever you want to perform a task, the main thing you have to think about is that, okay, after planting and harvesting, do I want the crop to regrow, or do I want it to just go off so that I plant something new? If you want it to just regrow, then after harvesting, you do not need to do anything. It will go again and again and again for the number of years that you want to run it for. But if your intention is to just harvest and clear the land for something else, or to harvest and allow it to regrow, if you want it to just be harvested and then you are done with it, then know that you have to use this kill operation. Don't forget, it's key. Otherwise, your model will run this way for the number of years that you run it. Okay, I think at this point we can go to our operation file to just have a recap of what we did yesterday. Okay, so we have 4 here. What do I do? Can you help me? What should I do? First, we have 4 files here. Should I read? Should I write? Should I run? Should I
Read.
get files?
Read.
I have to get files.
Okay, yeah.
So first I have to get files. Till.stat. You see it's different from what we had at first, so that if we had just read, we may run into errors. So we get files, we read. Okay, this was the problem that we were facing here today.
Now read. Yeah.
Yes, good. So it's a long list of things here. Don't get confused. Each of them has a meaning. So this one is the tillage or equipment operation name. And then the power code. You may want to keep in mind or look out for the IHC at this point. Yes, this is very important. This consists of a number of operation codes. 1 being kill crop, 2 harvest without kill, 3 harvest once without kill, 4 tractor. So it specifies in details the operation codes that you can use. For example, the first few ones that we have are just showing IHC code of 4 here. IHC code of 4. So what is IHC code of 4 telling us? It says tractor. So it gives you an idea of what is happening or the kind of activity that you have to perform. Okay. So this is one way by which you can easily determine and have the code for an operation. Here, IHC code of 8, for example, is talking about irrigation. IHC of 2 is talking about harvest without kill. So let's look for 2, for example. I mean, we can just sort and do this easily. But let's just look for 2. Yeah. Here it's telling us 2. Okay. Let me highlight that as well. So 2 is talking about harvest. So immediately you come here, you know that this is a harvest operation. Is it clear? Okay, let me go over it slowly. Here. Please, can you see from behind? You can't see, right? You can try. The IHC is important, so you can look for it in your tail.dat file. Tail.dat file, and then you go right down to IHC. Are we there?
Yeah.
Okay. So look, IHC of 0, it's talking about a plow operation or a cultivate or other. IHC of 1, it's talking about kill crop and so on and so forth. Look at IHC of 8, IHC of 9. It's telling you to fertilize, right? So, for example, let's try to work with IHC of 8. So, IHC of 8 is irrigate. So, from the IHC list, you look for 8. You can just use the sort and filter to find 8, or you can go through the hard way. So the IHC is what I've highlighted in yellow. Let's look for an area where we have 8. That's what. Yeah, yeah. I'll undo it. Yeah. So I see of it irrigate, right? Okay. So once you see an IHC code of 8, it's telling you that the operation is an irrigation operation. So you will see here, everything here is talking about irrigation. Are we good? So once you go to the details, you will find out that it's talking about the different types of irrigation. So when you use a code of 500, you are saying that you want to use a pivot sprinkler, you want to use, I don't know what this is. So these are all the different ways of irrigation. So here we see that there is drip and so on and so forth. So this is what the IHC basically, it gives you an idea before you go through the detailed list. So if you want to look out for an operation, you just would want to go to the IHC. Look, am I looking for 0, 1, 2, and then once you sort it out, you can. It's like a quick way of finding and selecting the kind of operation that you want to have. Is it clear? So now what do I do to go back? Using the, okay, I'm back, right?
Yeah.
Yes, I'm back. Okay, so that's it with the IHC codes. This is where we derive all our short codes that we were talking about yesterday. This is what we got them from. So the ones that were provided for us yesterday were just the most common ones that we mostly use on our farms. But depending on your purpose, it could be more. You may need more or less of these different types of operations. So we can go to, okay, so this is the IHC codes, the most common IHC code. So you remember 0 up to 8. So for our exercise, we made use of this common IHC code. Then for the details, we had these ones. So an ID of, for example, 136 is telling you that it's a planter. So you will plant, you will plow, you will fertilize, you will harvest, you will kill, then you will irrigate. I don't know why we would want to irrigate after killing. Okay, so these are just the codes that we can keep at our fingertips.
So that's the common.
The common ones
Or-
that we mostly use.
Yeah.
Yeah,
So
not in the
order.
particular order, yes. It's not in the particular order. Yeah, so yeah, there is an example here that we can simply refer to. So based on what we learned yesterday, right? If you have an operation like this, simply by looking at the structure, you have an idea what they mean, right? For example, by just looking at it from yesterday, what crop do you think this is?
Corn.
Corn, because yesterday we practiced a lot with corn. I'm sure if I asked about barley, we won't know. Yes, so this is where we got all our important information from. So we have the four here, so we have to get fast. That's the first thing. And then we read. So again, the detailed names are given here. So depending on what you want to work with, you can just replace the crop ID here. Okay. So first we detected our crop ID. What again have we detected? Apart from the year, the month, and the day, what again stands out? Even before understanding the detailed meanings, what can you see? Okay, for me, another thing which stands out is this 2000. Okay, in OPV 1, whenever you see the crop ID, you look at the OPV 1 and you see that there is also something at OPV 5, it should ring a bell that is talking about the potential heat unit and then the number of plants per meter squared at the point of harvest. Okay, so this is the potential heat unit. We will calculate it in a bit. And then this is mostly from literature. If you've conducted a number of field experiments and you see that your site um, is doing well with a different number per square meter, you can refer to literature, compare, and see how to adapt it to your model. So this we've also fished it out, even before coming or understanding the operations. This will give us an idea. And then when you continuously practice with the model, I think operation 451 will stick, and then operation 292 as well. Mostly 451, if it's not an annual crop, and if you want to just harvest and kill it and not allow it to regrow, you make use of the 451. So this is also something that can stick easily. So by just looking, you know that this is what it means, and then harvest. And then also here, by looking at these together, you have an idea that okay, this is a fertilizer application code, and the 65 is talking about fertilizer, and then the 20 is talking about the rates, right? Yes. So let's try to go back to our editor and then try to understand some of the things that we did yesterday. Okay, we get found. What is happening? Okay, okay, yes, the exact thing I was talking about. So we change this to OPS. Okay, okay. So we have our corn dot OPS. How should I use that in confuse? How do I do it? Oh yeah. Okay, so this is our corn operation that we did yesterday. So this is the year. We have just one, so it's telling us that it's just within a year, first year. And then the month is also easy, and the day. So this talks about the operation. So we have here 250, 250, 250. If we still want to find out what 250 is, we can just simply refer from here. So we are tilling the land. We did that 3 times. 15th of May, 1st of June, 15th of June. I think I had a number of people saying that this is a typical thing that is done on the ground. And then the crop ID is telling us what crop. And then the machine ID. If you are interested, you can give the specifics of the machine that is used for the operation. OPV0, pesticide site ID, is that it? OPV 0 at this point. Fertilizer or pesticide, yes. And then the rate of application, and so on and so forth, until OPV 7. OPV 3 talks about irrigation. We remember that irrigation can be either manual or automatic. We have zeros here because we are referring to just the manual. So you can also have irrigation, and whenever you apply irrigation, don't forget to end it at a point. I think we had an example when we did that. We'll check afterwards. Runoff versus volume of irrigation water applied. So this is with reference to the specifics of the fraction of each irrigation application that is plus to runoff and so on and so forth. So by just looking, we know that this is our potential heat units, and then this is number of watts per meter squared. So we might just want to recap a bit about how we calculated the potential heat units. So the heat accumulated until harvest. So we go to, is it in the software? Potential heat unit. Yeah. So this is a heat unit calculator that an alumni of Abramovich has been generous enough to create for us using the governing statistics behind it. So he's made our work easier. Yeah, yeah. So mostly he's very good at making things very easy and simple for everyone to understand. So when you just look at it, the things that he's highlighted in yellow are the things that you can touch. The things that are not highlighted is not for us. It's backed by the statistics or the calculations behind it. So whenever you see this yellow tick in any of Abiu's files, be sure to know that he's telling you that these are the places to play with. Okay. So he's saying that we should change the planting date depending on when you are planting, because depending on crop or the type of thing that you are doing, rainy season, dry season, this will change. Okay. So planting date, harvesting date, crop ID, because you would want to know the heat accumulated until harvest. Planting, harvesting, this, and then also long-term temperature. And we have a hint here. For what is available now, the temperature, T maximum and minimum temperature of station NEMO had been used. But we have our own database, so we would want to go and check and use our own maximum and minimum temperature sets, right? So for this exercise, so our planting date, when did we plant? You can tell me when we planted.
Which one?
June, June 15. Keep in mind that whenever you see PHU and this, it talks about planting. So 15th of June. Month, day, year. So the month is June, right? And the day is 15. Let's say we are in 2015. So we will not change the year. And then, when did we harvest? When did we harvest? Did we harvest on it's even obvious here, it's the same as the kill operation. So, Teddy, we can kill the day after, right? It shouldn't be the same day. Yeah, okay. So we harvested on 15th of October. Okay. Now our crop ID, we are using corn. This shows that we are working with corn. So one thing also that you have to keep in mind when you get into this potential heat unit calculator is that you don't have to refer to the crop ID of the database. Just go to the crop database in the heat unit calculator and then find, I think in the Apex editor, the method is 73, right? Let's check so that this will also stick. Um, yeah, so you see that here it's 73 for tomatoes, but here it's 72. So just keep in mind that you have to use the database that comes with the Excel file. If you give it 73, it's another crop, and you may have wrong calculations. So this you also have to keep in mind. Okay, we have 72. Now we go and bring our Tmax Tmin from our observed data set. Did you do that yesterday? Please, were you able to copy paste and then calculate the heat unit on your own?
Yeah.
I want to know so that I either go through it or we just skip.
Are we working on corn or tomato?
We are working on corn.
So we have to change the crop code. Crop ID. Number.
Yeah, he's right.
Oh, thank you. That means you are following. Thank you so much. But don't forget the tomato bit. Thank you. Okay, good. Okay, now we assume that we've got our station data set, T maximum and T minimum. Once you paste it, it automatically picks it up and it calculates your potential heat unit for you. I think this is simple. So, yeah, let's go to our. Okay, are we good to this point? Because once you understand the basics, you can do everything. Please, are we okay to this point? Okay, so what else to know? So this is corn without irrigation. Corn without irrigation. Once you are done doing this, you would want to make sure that your sub-area file, we haven't seen it today. So you go to get files in Apex. Okay. So you would want to make sure that your sub-area file and your ops.dat file in your Apex Pro are all saying the same thing. So for example, here for the operation schedule, we are seeing 141. Okay, where is this 141 coming from? Let's see if we can find it. So these are the main things that you look out for. After preparing your operation file, you have to make sure that your ops.dat in the Apex Pro is in sync with what you have done and what your sub-area file has, the information, so that you will pick and run with it. So this is also another basic thing that you have to keep in mind. OPS, okay.dat file. I remember yesterday we did a lot of things, moving up and down. I'm trying to help us to make sense of what we did yesterday. So we have a list of activities that have already been saved. So for example, one is saying barley, dry land, convention till, but we've also done our own thing which talks about corn without irrigation. So we want to introduce it here. So I think that the only thing we introduced here was 139, and it's corn with manual irrigation. Okay, let me check here. Okay, so when you look here, you will see that it's 141. Okay, our sub area. Let me close the potential meeting later. So our sub area is telling us that currently we have operation 141. So you ask yourself, what is this operation 141? When you come here, operation 141 is tomato with irrigation, and we've even specified the type of irrigation. So assuming we don't check and change this, and we just run our model, we'll be running a different thing. We want to run corn without irrigation. So imagine if I just hit this one, it will be a different thing. So the two key things to keep in mind after you've prepared your schedule is to make sure that the OPS or DAT file, the sub area file, and this schedule are speaking the same language. Okay. So now it's corn without irrigation. So we included it. So whenever you introduce a schedule, you have to come and define it here if it's not already defined. If we had done TEF, dry land conventional till, we could just use this 137. But what we did was not in it, and I see that we added it at number 139, right? So we come here to our sub area, and then we call this 139. Okay, then we write. Teddy, am I missing something? Can we run now?
Yeah.
Okay, so this is just it. All the complications about yesterday, this is just it. So now you can do anything that you want to do, right? Was the explanation clear enough?
Yeah.
Okay. I'm particular about the basics because once you get it, you can fly, you can do everything. Okay, so let's run and see. Okay. Okay. Let's see some of the results that we have. Okay. So this is the rainfall, irrigation, PET, ET. So we can look out for all the details that we are interested in, and then do our nice graphs and plots. Also, you can have a look at your Okay. So you have it with all the stress. So here we see that nitrogen is stressed at some point and it's quite high. So here you might want to introduce nitrogen. It's fine. Okay, so we might want to try our hands on the other exercises and compare. If you did something wrong yesterday, this is the chance to go back and get it right. I know that yesterday there was confusion about what to do after the schedule. So your sub area, if it's a new schedule, you have to define it in your OPS.DAT and give it a code. And with that code, you copy and then give it in the sub area.